Aha! X for the win again. Yes!
Oh, I hate losing. X's are pretty cool though.
Like treasure maps, X marks the spot.
Yeah, pirates, I get it. But also for the story we're telling.
I know, good old photo 51.
That's right. Without this fuzzy X, we wouldn't know what DNA looked like.
Hey, did you want a rematch?
No, I want to tell the story of how the structure of DNA was solved.
That is actually a pretty good story, and I do love storytelling. Let's get to it this week on
DNA Decoded.
Crafts? I love crafts.
It's really more of an engineering project.
Kind of looks complicated.
Pretty simple, really. Well, if you have the instructions. We've already seen how the DNA double helix is made up of smaller subunits.
The nucleobases.
Technically, with the sugar and phosphate bonds, they're called nucleotides. Nucleobase plus a D sugar and a phosphate equals nucleotide. We've already learned in the previous video that each of these units, the nucleotides, are repeated over and over to create a twisted ladder.
If you have easy to follow instructions,
easy peasy,
and you know the actual shape you're aiming for.
Yep, the instructions lay it out all for me.
But Kate, what if you didn't know the shape?
Well, that would be an entirely different ballgame, kind of like building a plane without a blueprint.
So how did somebody figure out that DNA was a double helix?
It wasn't one person. It took decades and lots of scientists worldwide. That's the way scientists work. Somebody figures out DNA exists, somebody else discovers the nucleobases that make it up, and the initial rules for how these nucleobases are distributed in the DNA helix, and so on, until eventually the double helix comes into focus.
Like the Watson and Crick guys, they were the first DNA decoders.
That's right, Francis Crick and James Watson, 1953. These guys, along with Maurice Wilkins, all share the Nobel Prize for discovering the structure of DNA.
But like you said, a ton of other researchers helped in this process by identifying key pieces of the puzzle.
Right, and we've only scratched the surface. Check this out.
Ah yes, photo 51. I get shivers, actual shivers when I look at this. I mean, this is a true piece of history. If I had a time machine, the first thing I do is go back to 1952 to witness the creation of this photo.
I'm with you all the way. And bonus, we get to meet Rosalind Franklin. Yes, Rosalind Franklin, along with her PhD student, Raymond Gosling, are credited with taking this picture. Watson and Crick, and all of the rest, were in a race to piece together all the data they had amassed about DNA in order to figure out its structure. They were working backwards, without a blueprint.
Next to impossible.
But did it stop these scientists? No, it did not. They proposed all manner of shapes for DNA. Even Linus Pauling, a double Nobel Prize winner, got it wrong. He proposed a triple helix structure for DNA.
And there were others too, including Watson and Crick. But no one had any proof of the structure of DNA. I mean, it's super tiny, so you can't just pop it under a microscope and see the exact shape in 3D. Not until this image. Rosalind and her graduate student placed a bit of DNA in front of a beam of X-rays. When the X-rays encountered a molecule of DNA, the X-rays were diffracted. Using some pretty serious math, you can use the diffraction pattern to figure out the position of the electrons and the atomic structure of DNA. So really, what we're looking at here is the base pairs, the insides of the DNA helix. But Watson and Crick focused more on the X. The repetitive structure of the X revealed that DNA was shaped like a double helix. It was this image that gave Watson and Crick a critical piece of evidence they needed to work out the structure of DNA. They got out some scissors and some cardboard and began piecing it all together. But Rosalind Franklin was not given her due credit, and she did not share in the Nobel Prize for the discovery of the structure of DNA.
Unfortunately, she died 5 years after the structure was solved.
And Nobel Prizes can't be awarded?
Posthumously, exactly.
Sad. Thanks, Rosalind.